Well, class, I'd like to welcome you to the first episode of Math 1050 College Algebra here at Utah Valley State College. I am Dennis Allison in the math department, and college algebra is a course that's important to a number of disciplines here at UVSC. For example, if you want to major if you want to major in business, before you can take business calculus, Math 1100, you have to take college algebra. If you're majoring in engineering or physics or even mathematics, let's say, you take college algebra and then trigonometry before you take calculus 1, which is Math 1210. If you want to be an elementary school teacher, you take Math 1050 college algebra before you take a 2-course sequence in mathematics for elementary school teachers. Then there are a number of disciplines that have college algebra as their math requirement, but you don't take any other mathematics beyond that unless you just want to. For example, if you're a history major, a psychology major, something like that, there's a math requirement, and college algebra is one of the courses that would meet that math requirement. One of the, or the course that's the prerequisite for college algebra is Math 1010, intermediate algebra. And today we're going to be talking about just some of the topics for Math 1010 that students are either a little rusty on or they have a little trouble with at Math 1050. So I thought we'd spend just this first episode going over some of those topics. And while I'm at it, I might mention to you some of the differences between intermediate algebra and college algebra. If you think back to when you took intermediate algebra, you may remember that course is mostly about, let's say, solving equations like quadratic equations, factoring polynomials, multiplying polynomials, simplifying radicals. In other words, it's more sort of, shall we say, computational. There wasn't much graphing. In fact, the only graphing that you do in intermediate algebra is to graph straight lines, and you probably graphed a few parabolas near the end of the course. Now, in this course, the emphasis is primarily on graphing. And we'll be using all of those ideas from intermediate algebra, solving equations, factoring polynomials, but we more or less assume that you know how to do those things now, and we move on to graphing. Graphing becomes very important in later mathematics courses, and sort of at the heart of graphing is the nature of a function. So today we'll be reviewing those intermediate algebra topics, and at the very end we'll also go over the notion of a function, some of the basic ideas that you need to know about functions. Now, to begin with, let's look at straight lines and the graphs of straight lines. There are actually 3 fundamental equations of straight lines that you need to know. In fact, you probably remember, I hope, from intermediate algebra. For example, there's the point-slope equation of a line. Who knows the point-slope equation of a line? Yeah, Jeff.
Y equals mx plus b.
Y equals mx plus b. Okay, so y equals mx plus b. And Jeff, what do m and b represent?
M's the slope and b is the y-intercept.
Yeah, m is the slope of the line. You remember that's the rise over the run, and b is the y-intercept. In fact, let me just make a note of that right here. M is, well, one way to put it is the rise divided by the run. Another way to put that is to say that it's, shall we say, delta y over delta x. That's the change in y over the change in x. And then, if you're given 2 points, let me just make a note of this over here. If you're given 2 points, x1, y1, and if you're given another point, x2, y2, then the slope of a line ends up being y2 minus y1 over x2 minus x1. So those are variations of what's called the slope formula. And that's the value of the m up here. B is the y-intercept, so B is where the graph crosses the y-axis. I mean, technically it crosses at the point 0b, but we'll just say it's the number b, and then we'll put it in right here. Okay, now, in addition to that, what is another equation of a line? In particular, maybe I should tell you, I'm thinking of the point-slope equation of a line, where you're given a point that's not necessarily on the y-axis and the slope. Who knows what that equation would be? Let me just draw an illustration over here. Suppose you were given a point x1, y1, and you were given a line that passes through it, and you know that its slope is m. What is an equation I could write for that line? Does anybody know? Well, let me tell you. It would be y minus y1 equals m times x minus x1. So in other words, if you know these two constants, x1 and y1, if you plug them in right here, y minus the y coordinate equals the slope times x minus the x coordinate. Have you seen that before? Yeah, so maybe you just didn't recognize it by the name I gave it. Now, there's another equation of a line where you put all the variables on one side, and it ends up looking like this. AX plus BY plus C equals 0. This is where A, B, and C are all constants. And this is sometimes referred to as the standard equation of a line. This is the point-slope equation of a line. And this is the slope-intercept equation of a line. Now, we have an interview with a student on the street, so to speak, and I asked the student a question about the equation of a line. So let's go to that videotape. Well, we're just outside the math lab here at UVSC, and I brought along a few questions to ask students as they come out of the math lab. This is Matt. I just met Matt. He's now one of my closest friends. But we're asking Matt a question on the spur of the moment, and I'm glad it's not me being asked a question on the spur of the moment. But the question I'm asking Matt today is this. What is the equation of this line? You notice it crosses the y-axis at 1, it crosses the x-axis at 2. And Matt's going to show us how to find the equation of that line.
Do you want me to tell you how I'd work it out, or just do you want me to work it out?
Oh, why don't you work it out, or
all right,
whatever you feel like explaining.
Well, it's going to be the equation of y equals mx plus b. And then your y is 1, so you go plug in your 1, your m, and your x is 2. And,
Well, class, I'd like to introduce you to a friend of mine. This is Jessica. I just met her here 2 seconds ago. And I'm bringing with me some questions, review questions from Math 1010. And we're just right in front of the math lab, so I'm catching students as they come by. They're my victims today. Jessica, I've got a question for you.
Yes.
Oh, by the way, what's your major?
It's elementary education.
Elementary ed. Well, good. Okay. I'm wondering, what is the equation of this straight line?
Okay. First, what you do is you start out with the equation y equals mx plus b.
Right.
And then what you do is you look at the line, and you find out where the line crosses on the y-axis, which would be the b. And so since it crosses at the 1, the b is going to be 1, and you need to find the slope. So it goes down 1 and over 2, so then you have a negative 1/2 x, and that's the slope of the line.
So the answer, let's see, the minus didn't show up. Maybe you can make that darker. Yeah, so the answer is?
Negative 1/2 x plus 1.
Y equals negative 1/2 x plus 1. That's exactly right, Jessica. Okay, why don't we just look quickly at the problem that I asked Matt and Jessica. Here's an illustration of that same line. I've changed the scale so that I can move the points out a little bit. So 1 is actually 2 strokes up above, and 2 is 4 strokes to the right. And so the line's coming down. Now, right away, we know this has a negative slope because this graph seems to be going downward as you move to the left, or move to the right. The y-intercept is 1.